and then we're going to put them together. Okay? So we're going to talk about them isolated, and then the next page is all about putting them together. Okay. Let's start with a product property. This just means if we have log base b of m times n, that is the same thing as log base b of m plus log base b of n. So the first thing we're going to do is we're going to work backwards. Okay? We're given this addition, and we're going to work backwards to get this multiplication. Okay? So, what is the question, Nolan?
I was wondering what the last letter was.
N, as in Nolan. Okay, so we're going to go through for number 1. First thing I want you to do, are the bases the same?
Yes.
Okay, so we can say log 2 of 7 times 4. And what's 7 times 4, guys? 28. Okay, see how that's nice and condensed? It's smaller. Okay, hence the word condensed right here. Okay. So who wants to try number 2? Go ahead, Cheyenne.
Log.
Mm-hmm. Yeah. Okay, and what is 25 times 4?
100.
Yep, because if you have 4 quarters, you have $1, remember?
I had to think about that.
If you think about it with money, I feel like multiples of 25 make it easier. Okay. All right. 3 is harder. So I'm going to do 3, but if you want to help out. So are the bases the same?
Yeah.
Okay.
So log 4.
So, yes. Go ahead, Nolan. Log 4. And then what am I going to do?
You're gonna
Multiply.
no.
Yeah.
Yeah. 8x.
8x to the
2x times 4x squared. I'm just going to do it in parts. You could have totally jumped straight to
So 8x. to the
log to the 4th, 8x to the
third.
3rd.
That's easy.
We're so smart.
You guys are?
But you just add the exponents.
Yeah. When you're multiplying exponents, you add them together. Okay? When you're dividing, you're going to subtract. Okay. Now, these ones, you guys could get a different answer than me. The answers vary. Okay? When we're expanding, the answer varies. What are 2 numbers that multiply to give us 6? 3 and 2. So let's use 3 and 2. So we can say log of 2 times 3 gives us log 2 plus log 3. And what base is this? Because it's not written there. 10. Good. Okay. We've got log base 7, 45. Who wants to try this one? Go, Michelle.
Log base 7 of 9 plus log base 7 of 5.
Great. Because 5 times 9 is 45, right? All right. Let's try 6. All right. We've got an X in there. Let's not let it throw it. Okay. You want to try it, Ethan? Okay.
Log base 2
Of is what we say.
5 plus log base 2 of x.
Perfect. That's it. So it looked complicated, but I think it was easier than number 5. Okay, that's product property. We ready to move on to quotient property?
Yes.
If you think by putting your phone underneath your table, I don't see you, I do, you need to concentrate on that. Okay, quotient property. Unless there's a question about product before we move on?
Nope.
Okay, quotient property. Log base b of m divided by n, we can do as log base b of m minus log base b of n. Log base b, m minus log base b, n. Yes?
How come we got this change it?
You might need to change it both ways, and I'm going to show you when we do a bunch of them. It's like, I need this expanded or I need this condensed, you know, it'll say. So first we're going to condense them. So we've got the subtraction and we want to change it into a quotient. So first I check the bases are the same. So I go log base 3, 24 divided by 8 gives me log base 3 of 3. Okay. Now I'm going to do the rest of these just to save time because I want to get to everything, okay? Because the next page gets way more complicated. So we get bases are the same. They both have 2. So I get log base 2 of 15 over 15, which gives me log base 2 of 1. Okay. Now I've got log base 4 of x to the 9th minus log base 4 of x squared. So this gives me log base 4 of x to the 9th over x squared. And what does that give me, guys? I've got 2. Yes, good. Log base 4 x to the 7th. Okay. Now, we're going to expand. Now, when we expand, you guys could get different answers from these. Answers vary. Okay, but I'm just going to go through these examples. If we have log 8, I want to think of 2 numbers. When I divide them, I get 4. I'm going to say 8 and 2. Okay? So that's the same as log base 8 of 8 minus log base 8 of 2. Okay? Now 1/3 is tricky because I have to think of numbers that can be used with that 5. So I'm going to try to, I'm going to change 1/3 to 15 over 45. We agree that 15 over 45 reduces to 1/3, right? But do we get that 1 and 3 aren't easily manipulated by 5? So that's why we're doing this, okay? So we get log base 5 of 15/45, which gives me log base 5 of 15 minus log base 5 of 45. So I didn't. I just wanted to do something where I would get, I multiplied it by the top and bottom by 15. Yes?
What if I did log base 5 of 3 minus log base 5 of 9?
I don't think you could do 9 because it's not divisible by 5. So try sticking it into your calculator, guys.
Does it have to be
Why
divisible
does it have to be?
It has to be.
I think it's because of that log at the bottom. But let's put it in our calculator. So, and check it out. So you said, so we get that if, like, look, if I do log base 5 of 1 minus log base 5 of 3, I'm just going to stick that flat out in my calculator. So I'm going to say log base 5 of 1 minus log base 5 of 3. And I want to see if I get the same answer as doing just this. So I'm going to stick this in my calculator too. Log 5 of 1/3. We do, so I don't know why we're doing that. I think I'm just showing you that you could get the same thing even if you did it different way. Yeah, I think this is dumb.
Right.
I think you can just do this.
Right.
Because couldn't you just do like log base 5 to like
Of 1 minus log base 5 of 3, right?
Yeah, exactly. And I just did it in my calculator. Gave me the same answer as what you did.
Yeah.
Right.
Okay.
Because like whenever we simplified it, we didn't have to do it.
I just think that was dumb. I don't know why. I think we're just showing that answers can vary. So if I didn't do 1/3, I could have done 15/45, and I would have gotten the same answer. Like if you put log 5 of 15 minus log 5 of 45 in your calculator, you'll get that same decimal.
But it doesn't have to be divisible by 5.
Yeah.
Just because it's-
I was wrong. Okay, log m over 7 gives us log m minus log 7, right? Okay. Power property. We've got log base b, m to the nth becomes n log base b of m. So we can go back and forth. If you have a number in front of the log b to the m, hi, I'm teaching you. We get an exponent, and we can go back and forth. Okay, so if we have 5 log base 4 of 2, that's the same thing as log base 4 of 2 to the 5th. Good? Okay, so 7 log 2 to the x becomes log 2 x to the 7th.
Log 8 to 1/3.
Okay, so this is iffy. Okay, that is true. Log 8 to the 1/3 is true. What can 1/3 be?
30.
So if I take something to the 1/2, that's the same thing as square rooting it, right? So if I'm taking something to the 1/3, that's the same as 3 rooting it, 3rd rooting it. This is important. I need you to know this. We did this a little bit before break. It was the stuff out of your book with radicals and exponents.
I don't remember that.
Okay. We need to work on it. Okay. Yes, Cheyenne? No. You got to know that one. Okay? All right. Number 16. Log base 2 of 8 to the 7th power becomes of 8. Okay, here's a tricky one where we're going to have to do something a little bit different. You see this exponent? We've got to move it to the front, but we have a 3 already there. So we're going to get 3 x minus 1 to the log of 4. So, can I simplify this anymore? I'm going to distribute, right? So I get 3x minus 3 log 4.
You said it get harder on the next page.
Yes.
It's actually about number 15. If we just calculated that, could we just put log of 2?
Yeah.
Okay.
So this can be simplified to log 2. Because what times what times what times what equals 8. And actually, technically, this would be your answer, what Michelle just said. So then you wouldn't have to worry about which one you did, because no matter what, you'd end up with 2, right?
That's what I just did. I just did
Yeah.
the 1/3.
So that like kind of eliminates that whole like worried about cube rooting it. Okay. We have log base 7 of the square root of w. So first of all, what is the square root? What kind of exponent can we turn it into? Good. Okay, so that was the tough part. The rest is easy because we've been doing this. What does it become? Log. Yeah, that's it. Done. Okay, now what we're going to do in the back is we're going to combine these. So we've just done product property, quotient property, and power property. Can you see that, Bree? Okay, now we're going to do multiples of them together. Okay, so turning this over. All right. We've got 2 log of 6 minus log of 9. Okay. first, we're going to do the product property, right? So I get, you can do them all together eventually, but I recommend breaking it down a little bit at first, okay? Log 6 squared minus log to the 9. So I just did the power property. Now this is what? This is the quotient property, right? So now we get log 6 squared over 9. And what's 6 squared? So we get log 36 over 9, which reduces to? 9 goes into 36 how many times? 4. That's our answer. Okay. We're looking at 20. Let me read the problem to you, and then you guys tell me what you're going to do first. Do you guys need it zoomed in back there? Michelle and Bree, you keep giving me. What is she doing? Squinty looks? Okay. We have 4 log base 4 of A plus 2 log base 4 of B. What properties am I going to use?
6 log base 4.
Power property, and after we do that, we're going to use, we have an addition in there. So we're going to use
The other
product.
What
Okay.
is 6 log base 4?
So you want to know what the answer is for number 20, or what are you asking?
Start. Would you do 6 log base 4? to
No,
start?
you can't add them together. That's a really great question. We have to do the product property, the power property first. So we get log, that's what I wanted to do too, Nolan. Log base 4, a to the 4th, plus log base 4, b squared. Now we can do the product property, correct? So that will be log base 4, a to the 4th times b squared, and that's it.
You don't do anything for us, 2.
Nope, because a and b do not match, right? So I can't put them together. Okay. So we're going to look at 21. Am I going too fast? All right, Maya, so maybe we should do it together then. Okay. So I want you to think about it. And this is where having this piece right here, where this is properties of logs, your like graphic organizer, might help you because you could leave it next to you while you're doing this. So we're looking at 7 log base 4 of u minus 3 log base 4 b squared. Yes, Eve?
So you know how we would like take the 3 and make it power?
Yeah.
Is it gonna be negative 3?
No. That's a great question. Okay, so the first thing we're going to do is do the power rule. So that becomes log base 4 u to the 7th minus, so I'm leaving the minus there. Did you see that, Ethan?
Yeah.
Log base 4 b squared to the 3rd. Because I have to move that 3 there, right?
I thought you would just like add.
All right.
I thought you would just add 2.
Well, we're not adding, we're multiplying though, right?
Oh yeah.
So I'm taking that step so you guys can see that this becomes log base 4 u to the 7th, that stayed the same, minus log base 4 v to the 6th. What is that rule called? What's quotient rule? Good. So I'm going to go log
Okay.
base 4 u to the 7th over v to the 6th. And then I'm done. Okay. I would like to skip down to number 24 because it's a little bit harder. And then I want to do some of the expanding ones because you have both on your homework tonight, okay? So I'm going to move to 24. All right, I've got 1/3 in parentheses log base 5 of 8 plus log base 5 of 27 end parentheses minus log base 5 of 3. You see that, right?
So we gotta do this.
So we got to do what's in the parentheses first. So we're going to do the power rule first, but we have to do it for both things inside the parentheses, right? So we're going to get log base 5, 8 to the 1/3, plus log base 5, 27 to the 1/3. And then we're going to just add on to the end, minus log base 5 to the 3 of 3. Yes. Yes. Okay. Now, what times what gives me 8? 2. So we get log base 5 of 2 plus log base 5 of what times what gives me 27? 3. Minus log base 5 of 3. So now we're going to do, if we look left to right like we're reading, I'm going to do product property first, and then whatever that answer it is, then I'm going to do quotient. Okay? So product property gives me log base 5 of 2 times 3 minus log base 5 of 3. And you could have done these together all at once if you wanted to. 2 times 3 is?
6.
Okay, so I'm just going to put that in. Log base 5 of 6 over 3, which gives me log of 5, base 5 of 2. Okay, I'm going to give you a minute to make sure you have this down, and then we are going to go do number 27 and 28 and 31. Okay, so we condensed. We made things smaller. Now we're going to expand. We're going to make them bigger. Okay?
Why we gotta make it
There may be cases where you want to do that. I don't know.
It's just
Are we gonna have to do that?
When
in
are
this
we gonna
Yeah.
use this?
Miss Murphy, are we gonna have to do that in this class?
What?
Cases where we gotta make it bigger.
Okay, so when are you going to use this? If you have something, if you have an exponent that you don't know what it is, you need to use logs to understand.
Or you would just make it smaller.
Okay.
Or you would make it bigger in that situation.
Okay, so if we're looking at 27, what if I knew what some of these were but not others? I've got to make them into separate logs so then I can take the exponent of them to solve what the x is. Yeah? Okay. So log base 6, parentheses, x, y, z to the 4th. So the
You could've
first
just
thing,
plugged that into the calculator.
right. So the first thing I want to do is separate these by product rule. So I'm going to get log of 6, base 6 of x, plus log base 6 of y, plus log base 6 of z to the 4th. And now, is there anything else I can do? I want you guys to start seeing it.
It's smaller.
So look at it. Is there anything else? So I undid,
Oh,
or I expanded on product. Is there anything else I could expand on?
you could move it forward.
I can move the 4. I can do power rule. So I have log base 6 of x plus log base 6 of y plus 4 log base 6 of z. We're going to do 28 and 31, and then that's it. Okay, 28. Log base 4 of a to the 9th over b. So the first thing we're going to do is we're going to expand using the quotient rule. So I'm going to do log base 4 of a to the 9th minus log base 4 of b. Now, is there something else I can do? The 9 power rule, yeah. 9 log base 4 of a minus log base 4 of b.
I didn't know where to put the 9.
Because of the power rule, right? The power rule tells us, okay, that if we've got log b m to the n, we put that n, that whatever that exponent is in front, log b to the m.
Okay.
Whatever exponents you see. Okay, I'm going to do 31, and then we're going to stop. Okay, 31, log square root of 7x to the third. First of all, what can I change my square root to? 1/2. So like for 32, it would be what? Because it's root 4? 1/4. Good. Okay. So first thing I'm going to do is power rule. 1/2 log 7x to the third. Next, I'm going to do product, right? Where I'm going to do 1/2 log 7 plus, I'm going to put this in parentheses, log x to the third. And then I can still undo that log to the third. Okay, I confused everybody. We're okay with putting the 1/2 in front, correct?
Yeah. And then you put the 3 in front of
Okay.
the log.
Yes, that's right, Nolan. 1/2 parentheses log 7 plus 3 log x. Now, I don't really like that 1/2 in front. So I'm going to distribute it to each one. So I get 1/2 log 7 plus 3/2 log x. I just did this. Times it by that. Times it by that. 3 times 1/2 is 3/2.
David, with the 1/2
wasn't just a
Right, because because the 1/2 is for all of this, it has to be for everything. Okay, before you do your homework, I do think it might be helpful to look at this graphic organizer before you do your homework. So I'm going to make a suggestion that even if you don't do examples, that we quickly write the rules in, okay? So this graphic organizer, I really do think this is going to make a difference. All right, product. If I go log b, basic logarithms. So log b of b, if we're going to change it into an exponent, that would become, well, anything b to the b gives you 1. Just like log b of 1 gives you 0. So if you go log to the 14 and 14, if you plug that into your calculator, you'll get 1. If you do log 3 to the 1, anything to the 1 like that, gives you 0.
Oh, because maybe like 2.
Yeah, because it's like, it'd be 14 to the x equals 14. Well, the only thing to be able to do that is 1. It'd be 3 to the x equals 1. Well, the only thing to be able to do that is 0. Okay. Product rule becomes log base b of m plus log base b of n. Log b m over n becomes log base b m minus log base b n.
We did this on the front page.
I know. Power rule becomes n log base b of m. And change of base becomes log a over log b.
Easy.
Okay? So have all of these in front of you while you're doing tonight's homework.
Okay.
Yes, this part right here. If you memorize this, you're good.
Are you serious?
We have a week and 1 day to do it. Okay? So maybe this would be a great thing where maybe instead of having it in a graphic organizer like this would be something like if you have this on one side and this on the other side for note cards, you know, to memorize.
Smart move.
All right.
What for the exams are we like? Have like that for like the
I will have to talk to Ms. Mouthbuff, but my thought is no.
We get one sheet of paper like this.
I will talk